Data-driven testing is a software testing methodology in which test data is separated from the test scripts, allowing the same test logic to be executed with different sets of input data. This approach enhances the coverage of tests by running the same test case with various input values, thus improving the robustness and flexibility of the testing process. Key concepts of data-driven testing. Test scripts, the automation code that defines the actions and logic of the test. These scripts are designed to be reusable and independent of specific input values. Test data, input data sets that are fed into the test scripts. This data can be stored in various formats, including spreadsheets, example Excel, databases, CSV files, JSON/XML files. Parameterization, the process of linking test scripts with data inputs. This allows scripts to accept external data during execution, making the tests dynamic. Execution engine, the tool or framework that reads the test data and runs the test scripts multiple times using different data sets. Benefits. Improved test coverage. By running tests with different data inputs, a wider range of scenarios can be covered, identifying edge cases and unexpected behavior. Maintenance efficiency. Changes to test data do not require modifications to the test scripts, making maintenance easier and reducing the chance of errors. Scalability. Allows easy scaling of tests as new data sets can be added without changing the core test logic. Reusability. The same test script can be reused with different sets of data, reducing redundancy and saving time in test creation. Common tools supporting data-driven testing. JUnit/TestNG, Java popular testing frameworks that support data-driven testing through data providers and parameterized tests. Selenium WebDriver, often used in combination with data sources like Excel or CSV files for data-driven web application testing. Robot Framework, supports data-driven testing with tables and reusable test templates. ptest, Python allows parameterization of tests with multiple data sets using decorators like @ptest.mark.parameterize. Example. Here's a simple Python example using ptest to demonstrate data-driven testing. Import ptest. #sample data for testing login functionality. @ptest.mark.parameterize, username, password, expected. User 1, password 1, login successful. User 2, password 2, login successful. User 3, wrong pass, login failed. dev_test_login, username, password, expected. #simulate a login function. Result equals login_function, username, password. Assert result equals expected. Def login_function, username, password. #mock login logic for demonstration. If username equals user1 and password equals password1. Return login successful. If username equals user2 and password equals password2. Return login successful. Else. Return login failed. In this example, the @ptest.mark.parameterize decorator is used to pass different username and password combinations to the test_login function, validating the login outcomes against expected results. When to use data-driven testing. Testing with multiple input combinations, especially when testing boundary values, edge cases, and negative scenarios. Regression testing where a consistent set of tests needs to be executed with varying data sets. Validating functionality that depends heavily on different inputs, like form submissions, API calls, or complex calculations. Let me know if you need more details on implementing data-driven testing with a specific tool or environment.